Hello, science fans! Welcome back to another thrilling journey into the unknown, where curiosity leads us to the very edges of human discovery. Today, we're diving deep, literally, into one of the most mysterious and least explored parts of our planet, the ocean floor. Beneath the rolling waves lies a world that is as alien to us as the surface of another planet. Imagine a place darker than night, where sunlight never reaches and the pressure is so intense it could crush a submarine. Down here, life has adapted in extraordinary ways, and the secrets hidden in these depths are only beginning to be revealed by science. Right now, Japan is preparing for a groundbreaking mission, not to search for gold or sunken treasure, but for something even more valuable in our modern world: rare earth minerals. These resources are the building blocks of our digital age. Rare earth elements are essential for powering our smartphones, electric vehicles, wind turbines, and solar panels. They're at the heart of the green technologies driving the future, making them more precious than ever before. Japan aims to be the first nation to mine these minerals directly from the seabed, thousands of meters below the ocean's surface. This is no small feat. It requires cutting-edge technology, remote-operated vehicles, and a spirit of relentless innovation. It's a massive national project, blending the imagination of science fiction with the determination of real-world engineering. The scale of this endeavor is unprecedented, and it could change the way we think about resource extraction forever. The goal? To secure a stable, homegrown supply of these essential elements and propel Japan into a new era of technological leadership and innovation. It's about more than just resources, it's about shaping the future. For decades, the world has relied on just a handful of countries for rare earths, leading to global supply chain bottlenecks and geopolitical tensions. A new source could transform the balance of power in technology and industry. Japan's plan is bold: tap into its own vast deep-sea deposits and become a major player in the global tech and resource markets. This could mean greater independence and resilience for the nation's economy. This is more than a quest for minerals, it's a quest for independence, innovation, and a sustainable future. By leading the way in responsible deep-sea mining, Japan hopes to set a new standard for environmental stewardship and technological progress. So, let's explore where this hidden treasure lies, why it's so important for our world, and what unlocking these resources could mean for the future of our planet and the generations to come. Ready to dive in? Let's get started on this incredible journey beneath the waves. Far out in the vast expanse of the Pacific Ocean lies Minamitorishima, also known as Marcus Island, a tiny, isolated speck of land that most people have never heard of. This remote outpost, surrounded by endless blue, is one of Japan's easternmost territories, and it's about to become the center of a global resource revolution. Located over 1,100 miles southeast of Tokyo, Minamitorishima is so far from the Japanese mainland that it takes days to reach by ship. Its isolation has kept it largely untouched for centuries. But the real treasure isn't on the island itself. It's hidden deep beneath the waves, in the vast underwater territory that surrounds it, an area that falls squarely within Japan's exclusive economic zone, or EEZ. This gives Japan special rights to explore and exploit resources found here. For years, scientists from JAMSTEC and other research organizations have been sending submersibles nearly 4 miles down to the ocean floor. Their mission: to study the mysterious mud that carpets the seabed. What they found was astonishing. This mud is packed with rare earth elements and yttrium, minerals that are essential for modern technology. These rare earths are crucial for everything from smartphones and electric vehicles to wind turbines and advanced military hardware. The deposits here are so vast, experts estimate there's enough to supply the entire world for centuries to come. It's a discovery that could change the balance of global resource power. Recognizing the enormous potential, Japan is moving quickly. The government and private companies are working together, aiming to launch a large-scale pilot project as early as 2025. This ambitious timeline shows just how serious Japan is about leading the way in deep-sea mining. The first step is to test new technology that can efficiently collect the mineral-rich mud from the ocean floor and bring it up to the surface. Engineers are developing advanced robotic arms and submersibles designed to operate in the extreme conditions of the deep sea. If these tests succeed, Japan plans to rapidly scale up to full commercial mining, turning this remote region into a hub of high-tech resource extraction. Right now, shipyards are busy constructing specialized mining vessels, and teams of engineers are assembling fleets of underwater mining robots. The scale of preparation is unprecedented in Japan's maritime history. Because all of this is happening within Japan's own EEZ, the country avoids the complex web of international legal hurdles that often slow down deep-sea projects elsewhere. Japan can set its own rules and move at its own pace. This gives Japan a massive head start in the global race for deep-sea resources. As other nations watch and wait, Japan is already taking bold steps forward. By focusing on their own territory, Japanese leaders are transforming what was once a forgotten patch of ocean into one of the world's most valuable strategic assets. The economic and geopolitical implications are enormous. The countdown to a new industry has begun. The world's eyes are on Japan as it prepares to launch a new era of deep-sea mining, one that could reshape the global supply chain for critical minerals. Will Japan lead the way and set the standard for responsible deep-sea mining? The answer may soon be revealed as the world watches this bold experiment unfold. Rare earth minerals aren't actually rare, they're just hard to mine. This group of 17 elements like neodymium and dysprosium are the secret sauce for modern tech. They make your screens vibrant, your speakers powerful, and your devices smaller and faster. Beyond gadgets, they're crucial for electric cars, wind turbines, and solar panels, the backbone of green energy. Without them, progress on climate solutions would stall. Japan's deep-sea project isn't just about more smartphones, it's about securing the future of clean technology. A new, massive source means cheaper electric vehicles, more efficient renewables, and continued innovation. Rare earths are the building blocks of tomorrow. That's why this mission matters. The stakes are high, the world is watching. Rare earths aren't just a science story, they're a story of global power. China currently dominates mining and processing, giving it huge influence over tech markets. If China restricts exports, the world feels it. Factories halt, progress slows. Japan's deep-sea mining is a strategic move for resource independence. Success would free Japan from supply chain risks and could make it a major supplier, shifting the global balance. Other nations would likely follow, diversifying the market and reducing geopolitical tension. This isn't just about mud, it's about redrawing the world's resource map. The implications are enormous. The race is on. Mining 4 miles down is an engineering marvel, pushing the limits of what humans and machines can achieve. The ocean floor is one of the most extreme environments on Earth, with pitch-black darkness, crushing water pressure, and near-freezing temperatures. Yet, the demand for rare earth minerals has driven engineers to develop incredible new technologies to reach these hidden resources. Imagine a giant underwater vacuum cleaner. This is a robotic vehicle, remotely operated from the surface, that crawls slowly across the seabed. Its job is to scoop up mud that's rich in valuable rare earth elements, which are essential for everything from smartphones to electric cars and wind turbines. The collected mud is mixed with seawater, creating a slurry. This mixture is then pumped up through a massive riser pipe that stretches all the way from the ocean floor to a ship waiting above. The pipe must withstand enormous pressure and constant movement from ocean currents. Once on board, the slurry is carefully processed. Water is separated from the mineral-rich mud and treated to remove any contaminants before being safely returned to the ocean. The concentrated mud is then stored in secure containers ready to be shipped back to processing facilities in Japan or other countries. Every step of this process relies on cutting-edge technology designed to survive the ocean's harshest conditions. Equipment must resist corrosion, withstand freezing temperatures, and operate flawlessly under immense pressure. Highly trained operators control the robot in real time from the ship, using live video feeds, sonar, and advanced sensors to guide every movement. Their expertise ensures the robot can navigate the rugged terrain and avoid obstacles on the seafloor. The riser pipe is a marvel in itself, strong enough to handle the weight and pressure, yet flexible to move with the waves. Powerful pumps work non-stop to push the heavy slurry up to the surface, overcoming gravity and resistance. When the ship's storage tanks are full, it returns to port. There, the mineral-rich mud is unloaded and sent to specialized facilities for the final extraction of pure, rare earth elements, which are vital for modern technology. This entire cycle, from the depths of the seafloor to the shores of industry, represents a remarkable feat of modern engineering, teamwork, and innovation. The future of mining is here, unfolding beneath the waves, where science and technology meet the mysteries of the deep ocean. Let's meet the machines making this possible. The surface production vessel is a floating factory, packed with cranes, pumps, and processing gear. Below, a tank-like robotic collector crawls the seabed, gathering mud with precision. Designs vary. Some use rotating drums, others water jets, but all aim to minimize environmental impact. High-definition cameras and sensors guide every move, sending data to operators above. The riser system, a 4-mile-long pipe, connects the robot to the ship, reinforced to withstand ocean currents. Submerged pumps help push the slurry upward. Support robots inspect, maintain, and monitor the operation, while underwater sensors track environmental changes. Constant monitoring is key to minimizing harm. This is high-tech mining at its most ambitious. But what about the ocean itself? The deep sea is fragile and mysterious. Mining stirs up sediment plumes that can smother slow-growing corals and sponges, drifting for miles. Noise and light from machinery disrupt creatures adapted to silence and darkness. We know little about these ecosystems. Some species may vanish before we even discover them. Scientists warn of irreversible damage and call for a pause until we understand the risks. The central question: can we extract these resources without destroying the largest, least explored biome on Earth? The stakes couldn't be higher. Progress and preservation are on a collision course. The world must decide. The debate is fierce. Supporters say deep-sea mining is essential for a green future. Electric cars, renewables, and tech all need rare earths. They argue it's less damaging than land mining and vital for Japan's security and independence. With strict monitoring and new tech, they believe environmental impact can be minimized. Critics, including scientists and environmentalists, urge extreme caution. They warn of unknown, possibly permanent damage to deep-sea life and call for recycling and reduced consumption instead. Weak international laws could lead to a rush before protections are in place. Many demand a global pause until we understand the risks. It's a clash between innovation and caution, progress and preservation. The future of the ocean and our technology hangs in the balance. What path will we choose? If Japan pulls this off, the world changes. Deep-sea mining would become real, sparking a global rush as other nations join in. The market for rare earths would shift, prices could drop, making green tech more accessible. Japan would become a resource superpower, redrawing geopolitical lines. But environmental concerns would intensify, forcing urgent action on regulations. The world would face a defining choice: balance the need for minerals with protecting our last wild frontier. Japan's success could set the standard for how we treat the deep sea. Will we act with wisdom and caution, or repeat past mistakes in a new realm? The future of our oceans and our technology may depend on what happens next. What choice would you make?